In this video, I'm going to be demonstrating how to do a little simple setup to inspect these boreholes, looking for cracks. This is aluminum. This is a manual bolt hole probe. The little dark spot on the left-hand side is your pancake coil surface riding. If you look at that little split in the probe, that's to give it a little bit of spring action. So what I'm going to do first, my screen looks like it's broken there, doesn't it? But I was just playing around with my rotation control. First thing we're going to do is just lay our block down on the table, and we're just going to tap the coil to the material. Let me hit the erase button here so we can see what's happening to our impedance vector there. It's kind of all over the screen. So first thing we want to do is get that flat. So you go through the buttons and make sure your angle is selected. Then you're just going to, while you're tapping, just start to rotate that button or that knob. And remember, null is your friend, so null often. So when we hit the null button, we're going to balance our instrument circuitry. And now, just for fun, I'm going to scan over that flaw. But see, it's vectoring down like about 190 degrees, something like that. But we want flaws to vector up. So we're going to start tapping again. We're just going to hit this, or turn the knob until our rotation is about 180 degrees from what it was. So that'll make the flaws vector upwards. And now if I hit erase and then scan over my surface crack, now it's going the right direction, but it's still too small. So I'm going to go to the gain control. And while I'm scanning past that crack, I'm just going to start to bring the gain up. And by the way, I'm using 240 kilohertz. I could have used 300, 350, 100. It's all going to work for surface cracks. However, the phase angle will be different. So it just depends on what the objective of your test is really. And depends on if you have specific procedure requirements you need to follow. So here I'm just nulling again, and I'm scanning past that crack, and now you can see it. So to make indications easier to detect, you want the flaw signal to have more of a vertical component. And what's nice about most modern instruments is that you can individually adjust the gain. So here, if we just select the gain button, it's going to raise and lower horizontal and vertical gain simultaneously. But if we just wanted to crank up the vertical gain, we'll select that button. And then as I scan over the crack, I'm just going to start raising the vertical gain. And as you can see, it's really putting that up nice vertical. Let's take the angle back down a little bit. I'm going to tap, 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 like the dentist does. Tap, tap, tap. And I'm going to make sure my coil is flush with the surface, or normal to the surface, as they say. I'm going to hit null again. Okay, it's still a little bit off on the angle, so I'm going to crank it up a little bit. It's pretty sensitive. That's just one click right there. And that's our crack. All right. So if I wanted to move the data to the right a little bit to make more use of my screen, I can hit this display button. Sometimes you can hit it twice. And then you can just hit horizontal position, and then we can crank, tapping a little bit here. Crank the null point. You got to be careful to keep your coil on the surface of the part. Liftoff is the most troublesome variable in eddy current testing. However, we can use it to our advantage if we want to do something like measure paint coating thickness because it's non-conductive. Let me readjust. You can tell here that doing a setup is a lot of trial and error, but once you know what you're doing, it's not that bad. Okay, there's our horizontal. All right. Erase, and then I'm gonna erase. All right, now it went too far to the right. So I'm gonna go back into the display. The horizontal, I'm gonna crank it about there. Again, you can see how much difference it makes when you're just a little bit off with your liftoff. I'll go back and set the angle again. Okay. And again, that's our crack signal. That's the deepest crack in our standard. but it gives you a lot of vertical. So now, if we're satisfied with that setup, we can clear the screen. And then when you're actually scanning, you don't want to be staring at your screen the whole time, because you want to probably focus on the area that you're inspecting to make sure you're getting good coverage. So what we can do is put a alarm gate in here. So you got to push this button a couple times and you get into the alarm gate menu. So you can select a box or a circle. For this one, we'll just use a box. And then for the alarm type, that's a plus or minus. You're going to hit that until it highlights. And then you're going to select positive. That means anytime the impedance trace enters the box, it'll set off an alarm. If you set it to negative, you would null in the middle of the box, and then anytime your signal would leave the box, that's when you get an alarm. So we're using positive. And of course, the horn is a cool feature that will alert you when you're looking at your hole instead of the screen. Now we're pretty much all set up, so I'll just hit erase again. And you know, if the noise is setting the alarm off too much, you can just change the size of that box. And you do that by hitting the size, position, select bottom, and we can crank the bottom up a little bit, maybe like that. That way noise won't be setting off your alarm constantly. Okay, so now, oh wow, look at my noise, it's a little bit off again. So let's go back to main, angle, tap, 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 erase, scanning the material, and then when we pass a crack, we set off the alarm, see? There we go, it's all the same crack. Now, that was set up on the flat block over the crack, but what I want to do now, since we have our settings fairly close, I'm going to select the right hole, which is this one. And the crack it's on the bottom edge of this hole. So I'm going to start off with the coil on the top. So I'm going to stick it in there. I'm going to hit the null button. Okay, that puts us kind of down where we want to be. If it's off screen, you know, you'll just have to balance and hit the rotation button a bit. So what I'm doing right now is I'm just trying to figure out if my noise is pretty flat, which is not bad, but it is a little off. So let's just go in there and turn our angle a little bit. Okay, so this is where you're gonna, well, let's see, hold on. We still want that probe motion to be horizontal, there we go. So now I'm rotating the coil back and forth in a clean area of the hole where there's no flaw. And as you go from hole to hole, you'll come out and it'll give an alarm, because when your coil is unloaded in air, it's gonna give you a big signal, just like a great big crack. Now if I hit the erase button, you're going, where's my impedance point? Well, you balanced it in the material, so now your null point's way off screen somewhere. But as I put my coil back into the hole and it sees the material, it comes back on screen. So now as I'm scanning back and forth, it's pretty much staying out of the box. But when I turn this probe 180 degrees, you're gonna pass that crack, and that's when you get the crack. So that's pretty much the setup. And again, it's a lot of trial and error. The basics are, you want to null often. You want to be conscientious to make sure that your coil is flush to the surface. First, you're going to set noise horizontal on the block to get you close. What I'm going to do here is I'm going to balance it to bring it back on the screen a little bit. So again, this is tapping it on the flat part of the standard. And again, what we did was set noise horizontal flat there, scan past the crack, you can easily see it. Then, if we go back to the hole, put the probe in, hit the null button, scan a little bit, make sure that our noise doesn't go up into that box. And you can tell our noise is horizontal there. pretty much going back and forth horizontal. Erase. And then now when I turn the probe to pass the crack, there you go. And if you wanted to make this signal much bigger, you could just adjust the gain. Keep in mind that I have my vertical gain set about 20 points higher than my horizontal gain. We could do it even a bit further and just to see what it does. We're going to take the horizontal gain down a little bit. And what that's going to do is it's going to take a lot of the horizontal probe motion noise off of your display, which probably help you see flaws a little bit better. So now when I'm scanning back and forth, hold on there. Okay, erase. Now when I'm scanning back and forth, you can see there's not a lot of horizontal noise, right? Because that's we lowered the horizontal gain. And when I pass the crack, I got vertical. Keep in mind, if you don't null correctly or often enough, your null point can shift to the left or to the right of that alarm gate box, so you could actually miss a flaw if you're not paying attention. So what you could do, if you wanted, you can go into display and hit the sized box. And then for the right, we just make it a little bit wider to the right. And we can make it a little bit wider to the left. Then go back to main. Then we're going to hit null. Then we're going to move our probe back and forth a little bit. And hit null again. And see, now we're kind of too far off to the right. So what I want to do maybe is go to display, and we're going to just move it over to the left. So the null point on good material is right about in the center at the bottom of our screen. Hit null one last time. Scanning back and forth, scanning back and forth. And when I pass the crack, there you go. If you have any questions, feel free to give me a call.